Hello students, welcome all of you at AriserTalent. So, how are you all? I hope you are doing absolutely well. We are on the third chapter of the class 10th chemistry, that is metals and non-metals, and in our previous lecture we have dealt with so many topics and so many metallurgical and the extraction processes that we have discussed, that how will be the purification of the metal done, and few of the NTSE questions related to the chapter metals and non-metals. In purification method, we have gone through the three steps, that is what is liquefaction, what is distillation, and what is electrolytic refining method. So our today's topic is what is reactivity series. So reactivity series is basically a series in which metals are arranged according to the decreasing order of their reactivity. It means the metal which is more reactive is placed at the top of the list, and the metal which is less reactive is placed at the bottom of the list. So why metal reactivity series is so essential? Because for checking the chemical reactions, chemical reactivity and the chemical bonding of an element, we need reactivity series to check which element is more electropositive or which element is more electronegative. So the property of a metal differ from one metal to another metal. Some metals or non-metal react with chemical reagents very fastly and some will react very slowly. So for this discussion, we have to read or we have to learn the reactivity series of the metal. So students, we are going to start our new topic, that is what is reactivity series. So our today's topic is reactivity series. Reactivity series is a series in which metals are arranged in decreasing order of their chemical reactivity. So metals are specifically arranged in the decreasing order of the reactivity, as I have already said that the metal which is more reactive is placed at the top of the series, and which is less reactive or react very slowly will placed at the bottom of the reactivity series. So what will happen if an atom or element has a tendency to lose electron? We can say that this type of element is known as electropositive element. So the topmost element is the electropositive element because it has a tendency to lose electron. So what are electropositive elements? Electropositive element is tendency to lose electron. So element or the metal which will lose electron are termed as electropositive element, and the atom or electron which have the tendency to gain electron is known as the electronegative element. So what is electronegative element? Element having tendency to gain electron. So which have the capability to lose electron is known as electropositive element, and the element which have tendency to gain electron is termed as electronegative element. Now we will see the reactivity series and see how metal vary in their reactivity for their decreasing order. So this metal chemical reactivity series or metal activity series is known as activity series also. So it is termed by the another name, that is called metal activity series, or sometimes we may call it as a reactivity series. Now We are looking for a reactivity series in the decreasing order of the metal. So this is our metal reactivity series in which metals are arranged according to the decreasing order of their reactivity. So you can see here the lithium metal that is placed on the topmost of the list, or we can consider potassium, barium. These are most reactive metals. As we go down, the reactivity will decreases in the order. If I am comparing about the reactivity of zinc and iron, zinc is more reactive as compared to hydrogen, then nickel, and tin and lead I have drawn here. It means they have less reactivity as compared to these metals. So if we are going from top to bottom, the reactivity decreases, and if we are going from bottom to top, the reactivity will increases in the same manner. And the topmost element is the most reactive element and the lowermost element is the less reactive element. But there is a standard for consider it or for the comparison. We are comparing this table with the hydrogen atom. So remaining part of the table I am drawing here. So what are the other elements of this table? So this is the remaining part of the reactivity series I have drawn here, and I have told you that comparison is done on the basis of the hydrogen. It means all the elements or all the metals above hydrogen are more reactive as compared to other elements, and the metals below the hydrogen are less reactive. If the comparison is done, the comparison is done in reference to hydrogen only. So this is the remaining part of the table as I have connected from here. Copper, mercury, silver, gold, platinum are less reactive metal as compared to hydrogen. So we can say that the most reactive metals are lithium and potassium, and if I am telling about the less reactive metals, we can say that gold and platinum are less reactive metals. These are less reactive metals. If comparison is done on the basis of the hydrogen, we can see that metals above hydrogen are more reactive and metals below hydrogen are less reactive. So we can conclude one point from this conclusion: metals above hydrogen and metals below hydrogen. So if the hydrogen is considered as a standard, we can say that metals above hydrogen are more reactive and metals below hydrogen are less reactive. So hydrogen is chosen as a standard unit or the standard element for the comparison. Now the point is that in spite of being not a metal, not a non-metal, why hydrogen is included in the reactivity series as hydrogen is not a metal? Because hydrogen have a tendency to form the H plus positive ions apart from other ions, so it is included in the reactivity series. I am again repeating my point: in spite of being not a metal, why hydrogen is included in the reactivity series? It is included in the reactivity series because hydrogen will have a tendency to form H plus ions. So positive ions are formed, so the comparison is done on the basis of hydrogen. So this is all about the reactivity series. The basic definition is that the series in which the metals are arranged in the decreasing order of their chemical reactivities is known as metal activity series, and this is all about the metal activity series. Metal activity series is essential to check the chemical reactivity of any metal. So it might be important from your exam point of view or for the chemical reactions to occur or check whether the reaction will be completed or not. So now we are going to discuss about the significance of metal reactivity series, but before that you can copy it from here. So our next topic of discussion is what is the significance of metal reactivity series. So we are going to discuss about significance of reactivity series. So firstly, the first significance of the reactivity series is that metals are arranged in the decreasing order of their chemical reactivity. As we go from top to bottom, the tendency to lose electron will going to decrease because the topmost element is the electropositive element and the bottom elements are not electropositive elements. So the first point of consideration is that topmost elements are electropositive element or electropositive metals. Second point here is, as we go from top to bottom, the tendency to lose electron will going to decrease. So the second point for consideration is from top to bottom, tendency to lose electron will decrease. Tendency to lose electron will going to be decrease, because the electropositive character will going to decrease from top to bottom. Now we are considered, if any of the element react with, it means the metal above hydrogen when react with dilute acids, they will liberate hydrogen gas in the solution. So hydrogen is here in our reactivity series, and we can say that the elements or the metals which are placed above hydrogen when react with dilute acids, they will liberate the hydrogen gas in their solution. So the one more significance of the reactivity series is that metals above hydrogen on reaction with acids liberate hydrogen gas. So we are taking a general equation for the representation of this kind of significance in the reactivity series. Suppose I am taking any example. Suppose we are taking zinc or magnesium, any of the metal. Suppose we are reacting zinc with H2SO4. This is zinc, and this H2SO4 is our dilute sulfuric acid. So this is our dilute sulfuric acid. Now what will happen in this reaction? When the zinc is reacted with dilute sulfuric acid, it will form zinc sulfate and hydrogen gas will be liberated in the solution. So the compound formed here is zinc sulfate and hydrogen gas will be liberated in the solution. So we can see here, when the metals above hydrogen is going to react with any of the dilute acid, it will liberate the hydrogen gas in the solution. Now we are considering another example. We are taking an example for magnesium. Now we are going to react magnesium with hydrochloric acid. So what will happen here? When Mg is going to react with 2HCl, it will form MgCl2 plus hydrogen gas is liberated again. So you can see from here, when magnesium is going to react with dilute hydrochloric acid, magnesium chloride is formed with the liberation of hydrogen gas. So we can see that metals above hydrogen will going to react hydrogen gas. Now the last significance of the metal activity series is that the element which is more electropositive will replace the less electropositive element from the reaction. So we are going to discuss our last point, but you can copy it from here. The last point is more electropositive element will replace less electropositive element. Now we are going to conclude this point. Look at the reactivity series. You can see here zinc is more reactive than iron. Why zinc is more reactive than iron? Because zinc is placed above the iron in the reactivity series. So when the iron rod is dipped in the zinc sulfate solution, what kind of reaction will occur? We will see here. Example here. When iron rod is dipped in now what will happen in this solution if I am performing its reaction here? Iron is Fe, it is going to react with copper sulfate. As we see from the reactivity series, iron is placed above the copper in the reactivity series. The reactivity series we have drawn here, copper is at the bottom as compared to iron. So what will happen? Iron will replace the copper and form the ferrous sulfate solution. So what we will get in the product side? We will get FeSO4 plus copper is displaced. You can see from this reaction, iron here is displacing copper from its solution. So we can say that iron is more electropositive as compared to copper. So this is all about the metal reactivity series. This reactivity series is very essential for learning the chemical reactivity. So we can see the reactivity of the less reactive metal. Less reactive metals are those metals which are very on the topmost bottom part, on the bottom part of the reactivity series we have seen. So the reactivity for these metals, it means these metals can be extracted only by calcination or roasting, and after simply heating we can obtain the metal in the simpler form. So the reaction, we can consider the example for mercury for this reaction. Here we have 2HGS, this is mercuric oxide, mercuric sulfide, and we are heating it in the presence of oxygen. So we will get 2HgO and 3SO2 here. So we will get mercuric oxide and sulfur dioxide in this reaction, and we are performing simple roasting here. Now what we are going to do, we are simply heating that oxide. It means simply heating that oxide, we will get mercury plus oxide. It means less reactive metals can be extracted only by performing calcination and roasting in the first step, and secondly heating that metal we will get the particular type of metal. So this is our mercury metal. But this criteria can be performed only for the less reactive metals. Now we are moving to our next category, that what will be the reactivity or the extraction method for the medium reactive metals. So we have extraction of medium reactive metals. Now medium reactive metals are those metals which are in the middle section of the reactivity series. So we can consider here the medium reactive metals are not obtained simply by heating that material, it means by reducing it. Firstly, we have to react it with the particular type of elements, like we can heat it with carbon, carbon monoxide and aluminium, and this method is applicable for the metals like zinc, iron, lead, etc. So firstly, we are performing the reaction with zinc. Reaction with carbon. If suppose Fe2O3 is going to react with carbon, we will get FeO plus CO2. Now this oxide is reduced and iron is obtained from its ore. Now Our second reaction is reaction with carbon monoxide. If I am performing the reaction with carbon monoxide, what we will get, if I am reacting lead with carbon monoxide, what we will get? We will get Pb plus CO2. In this way, lead metal can be obtained from reacting with carbon monoxide. Now we can see the reaction with aluminium. Our third reaction will be reaction with aluminium. Reaction with aluminium I am writing here. If I am considering Cr2O3 and we are reacting it with aluminium, what we will get? We will get here chromium plus Al2O3. So these are the three reactions of the medium reactive metals with carbon, carbon monoxide and aluminium, and particular type of metal can be extracted from this type of reactions. So this is applicable only for the medium reactivity series. Now we are going to discuss about the last reactivity series, that how will be the reactivity for the higher order metals. It means if the metal is showing high reactivity, how it can be extracted. But before it, you can copy it from here. Now we have our last step, that is extraction for highly reactive metals. Now highly reactive metals are those metals which are on the top of the reactivity series. If I am considering about aluminium oxide, the aluminium oxide is a stable compound and this oxide or this extracted ore cannot be obtained from the simpler method. So what we have to do, we have to extract the molten salt of these type of the compound and perform its reduction, and the metal is obtained only at the cathode. If we are doing this type of reaction using electricity, so it is considered as a electro metallurgy, because the metallurgy is performing by using the electrochemical processes. So it is only for the highly reactive metals. So what we are doing here, we are taking Al2O3. This Al2O3 is actually aluminium oxide. This aluminium oxide, if we have to obtain the aluminium from this oxide, we will perform electrometallurgy. Electrometallurgy means metallurgy or extraction is done in the presence of electrochemicals. So what we are going to do is, we are taking Al plus 3. This is obtained from the molten salt. This is obtained from the molten salt. Now we are adding 3 electrons to it to get Al. So these 3 electrons and aluminium that we are obtaining, this aluminium is always obtained on the cathode part of the system, because cathode is negatively charged and the metals are associated with the negative part of the substance. So this aluminium is only obtained at the cathode, because negative particles are obtained at the cathode. So this is all considered in the electrometallurgy. So metallurgy or the extraction for highly reactive metals can only be done by this way. So we have discussed about the reactivity of low metals, medium metals and the high metals. Now we are only left with the refining and the purification method. That topic we will discuss in our next lectures. Thank you so much and have a nice day.